What is black carbon? For purposes of this discussion, is defined as unburned fuel and as a result of incomplete combustion. Black carbon is also produced as a residue when organic matter, such as wood, is burned, for example, during forest fires. But for our purposes, black carbon is the sooty black material emitted from gas and diesel engines, coal-fired power plants, and other sources that burn fossil fuels. It comprises a significant portion of particulate matter, or PM, which is an air pollutant. A solid particulate pollutant, black carbon is one of the major reasons for the increasing global warming crisis across the globe. When black carbon particles enter the atmosphere, they absorb sunlight and heat up the air around them. Unlike other forms of carbon, black carbon has more serious implications for human and environmental health, since it can be both airborne and can also get deposited on surfaces. Black carbon, due to its property of absorbing radiation, has some serious implications on the environment and contributes to global warming, only second up to and exceeding 1,500 times worse than carbon dioxide. Some facts and figures about glaciers in the world. Glaciers are huge masses of frozen freshwater. These act as reservoirs of freshwater and, under normal environmental conditions, melt at a slow but consistent rate to maintain the water level in the water bodies they act as a source for. Glaciers are not made in a day, but it takes hundreds or thousands of years for gigantic glaciers to take form. Glaciers vary in their appearance. Some are brilliantly aquamarine colored, looking almost ethereal, while some have a rocky appearance. About 10% of the Earth's surface is occupied by glaciers, but just after the last ice age, this area amounted to nearly 1/3 of the surface. While many glaciers are yet to be discovered, we have already lost many to the rising temperature levels. There are an estimated total of 100,000 glaciers in Alaska alone. Glaciers can be found in a total of 47 countries worldwide. Also referred to as frozen rivers, glaciers play an important role in regulating the water level in the water bodies around the globe. Glaciers form when several layers of snow deposit in the same region over the years. Antarctica's Lambert Glacier is the largest glacier of the world. How does black carbon play a role in glacier melting? Glaciers have been melting ever since we've known of their existence and before, but over the last few decades, the rate of melting glaciers has risen to an alarming level. Black carbon, too, has a major role to play in this crisis. Black carbon adds to the greenhouse effect since it absorbs sunlight. Black carbon deposited on the various surfaces decreases their reflective ability and promotes the absorption of sunlight on the other hand. This, in turn, enhances global warming and contributes to the melting of glaciers faster. Black carbon has a warming effect of over 1,500 times worse than carbon dioxide. Effect of glaciers melting in the world. Melting glaciers add to rising sea levels, which in turn accelerate coastal erosion and elevate storm surge as warming air and ocean temperatures create more frequent and intense coastal storms like hurricanes and typhoons. Specifically, the Greenland and Antarctic ice sheets are the largest contributors to global sea level rise. The current trends suggest that the Greenland ice sheet is disappearing 4 times faster than in 2003 and already contributes 20% of the current sea level rise. As this ice melts, darker patches of the ocean start to emerge, eliminating the effect that previously cooled the poles, causing warmer air temperatures and furthermore, disturbing the normal patterns of ocean circulation. Research shows the polar vortex is appearing outside of the Arctic more frequently because of changes to the jet stream caused by a combination of warming air and ocean temperatures in the Arctic and the tropics. The altered ocean circulation leads to the collapse of the ocean dwellers, which is a major loss of biodiversity. Coastal inhabitants face immense floods more frequently. It has also been observed that in the Arctic region, as sea ice melts, wildlife like walrus are losing their home, and polar bears are spending more time on land, causing higher incidences of conflict between people and bears. What will be the predicted future in the same situation of black carbon? Even if we significantly curb emissions in the coming decades, more than a third of the world's remaining glaciers will melt before the year 2100. When it comes to sea ice, 95% of the oldest and thickest ice in the Arctic is already gone. Glacial ice is heavy, and when it disappears, a massive weight is lifted from the land beneath it. That land responds with something called post-glacial rebound, in which it starts to bounce back up to its pre-glacial configuration. The effects aren't necessarily positive. In fact, this can lead to the formation of new lakes, land becoming cut off from other lands, and increased flooding. Frequent flooding and displacement of people will cause demographical imbalance. We simply have no idea how much biodiversity we are at risk of losing to this continuous alteration in ocean currents, temperature rise, and flooding. Many stretches of land will be engulfed by the oceans and lost. What should we do next to stop this? While black carbon is not the only reason why glaciers are melting worldwide, it certainly is the most prominent contributor to the crisis. Hence, it is imperative to curb the emissions of black carbon along with that other such pollutant that aggravate global warming to see a substantial decrease in the rate of the melting of glaciers. Humanity is dependent on energy that is not subject to change. Currently, 95% of that energy is made from fossil fuels. Even though there is a serious commitment toward renewable and clean energy production, fossil fuels will be the source of energy production for decades to come. It is this burning of fossil fuel that creates most, if not all, of the black carbon that is causing the glaciers and ice sheets to melt. There has been over an 85% increase in black carbon in the Arctic and polar regions as opposed to just 4% in other regions of the world. This is due to increased shipping, exploration, and tourism in these regions. Although the elimination of black carbon is more than a daunting task, and we are already far behind in this race against climate change, the good news is that over the last several decades, mankind has done countless studies using hydrogen to improve the combustion of fossil fuels and reduce unburned fuel or black carbon. There are countless studies from MIT to SAE to universities in every country that have proven that hydrogen can be used to reduce black carbon emissions from fossil fuels. This technology simply has not been commercialized. That, among other things, is the function of the Black Carbon Coalition, to bring to commercialization technology that reduces and eliminates black carbon. In a hydrogen economy, hydrogen would be used in place of the fossil fuels that currently provide 4/5 of the world's energy supply and emit the bulk of global greenhouse gas emissions. This could aid climate goals because hydrogen only emits water when burned and can be made without releasing CO2. However, this hydrogen economy cannot be transitioned into in the next 100 years. We don't have 100 years. We have to act now to burn our existing fuel better and develop technologies to eradicate black carbon.